Hi students, today we are welcome to physics class. Today we are going to discuss about stopping. Stopping distance. Stopping distance of vehicle. Stopping distance of vehicles. Once again, today our concept is stopping distance of vehicle. Now, what is stopping distance of vehicle? Suppose when we apply a brakes to any moving vehicle, the distance it traveled before stopping is called stopping distance. That means, suppose here there is one vehicle. Now it is moving in positive x direction, in this direction. Here I applied the brakes. This vehicle now came up to here and stopped here. After applying the brake, how much distance it is covered? Suppose, say, from here to here, half meter. This half meter we called as stopping distance. Okay? Now, go for the definition. Go for the discussion. When brakes are applied to a moving vehicle, the distance it travels before stopping is called stopping distance. Now it is depends on the initial velocity u. It is depending upon the initial velocity u and the braking capacity or deceleration that is negative acceleration, we also called as minus A. We also called as minus A is caused by is caused by the braking. Is caused by the braking. Once again, I am repeating this content. When brakes are applied to a moving vehicle, the distance it travels before stopping is called stopping distance. It is depends on the initial velocity u and the braking capacity or deceleration minus a is caused by the braking. Now, this is about stopping distance. Now we are going to discuss a numerical about stopping distance. Now go to numerical. Numerical. Derive an expression for stopping distance stopping distance of a vehicle in terms of u and a. Once again, I am repeating the question. Derive an expression for stopping distance of a vehicle in terms of u and a. Now, go for solution. Once again I am repeating the question. Derive an expression for stopping distance of a vehicle in terms of u and a. Now go for solution. Let the distance traveled by the vehicle before it stops. By before it stops. B ds means stopping distance. Once again I am repeating this point. Let the distance traveled by the vehicle before it stops be ds. We know that v square minus u square is equal to as. Here s is equal ds, stopping distance, and acceleration a is equal to a only. The final velocity v is equal to 0. Initial velocity U is equal to U. Now, substitute these physical quantities in equation number 1. Therefore, ds is equal to minus u square. Therefore, 0 minus u square is equal to 2a ds. Therefore, ds is equal to minus u square by 2a. This is equation number 1. Now, therefore, the stopping distance the stopping distance is proportional to, this is equation number 2, 0 square final velocity minus initial velocity square is equal to 2a into stopping distance. Therefore, ds is equal minus u square by 2a. Consider this is equation number 2. Therefore, the stopping distance is proportional to the square of the initial velocity, the square of the initial velocity. Okay, now once again, the stopping distance is proportional to the square of the initial velocity. Square of the initial velocity. Now, go for one note. Note means important point. Note. Doubling the initial velocity increases the stopping distance, the stopping distance by a factor of 4. Once again I am repeating this point. Doubling the initial velocity increases the stopping distance by a factor of 4. This is the important point. Now we are going to discuss about reaction time. Now we are going to discuss about reaction time. What is reaction time? The reaction time means it is the time a person takes to observe, think and act. If a person is driving and suddenly one person came, example, take a car. Here there is a driving who drives in a positive x direction. Suddenly a person came here. Suddenly a person came here. The driver, he who is unable to collide the person. This person, that means this driver, immediately see the person and think about the person and act accordingly, means he will apply the brakes. So for all this purpose, he will took some time. That time we can call as reaction time. Now go for derivation. Sorry, go for explanation. Reaction time. Reaction time is the reaction time is the time a person takes a person takes to observe takes to observe, think and and act and act. If a person if a person is driving if a person is driving and suddenly a boy appears. Suddenly a boy appears on the road comma, then the time then the time elapsed before he slammed the brakes. Slam the brakes of the car is the reaction time. Now once again I am repeating the point. Reaction time is the time a person takes to observe, think and act. If a person is driving and suddenly a boy appears on the road, then the time elapsed before he slams the braking of the car is the reaction time. Now reaction time depends on complexity complexity of the situation and on an individual. Once again I am repeating the point. Reaction time depends on complexity of the situation and on an individual. Therefore, the distance traveled, the distance traveled is d is equal to 1 by 2 g t square. Consider this is equation number 1. Therefore, the reaction time is small t is equal to root of 2d by g. Consider this is equation number 2. Once again I am repeating these 2 points. The distance traveled d is equal to 1 by 2 gt square. Consider equation number 1. Therefore, the reaction time small t is equal to root of 2d by g. Consider equation number 2. This is about reaction time. My dear students, I hope you understood what is the reaction time. However, thank you very much for watching this one. Thank you.